so water already has H plus in there. It doesn't have any A minus in there at all. Okay? There's no A minus in there. But so when you put an acid, the more concentrated this acid, the smaller the number that X is going to be. Smaller the number of X. Or the amount of it as compared to your initial concentration is going to be lower. Percent dissociation will always increase as this decreases for every acid. Water is getting more from H plus, and so you're getting a shift in which direction? Yeah, that's right. So it's like this. The only number that's actually incorrect up here right now is which one? H plus. Right here. This is actually what? Impure water. 1 times 7 to the negative 7, right? So it's not technically 0. But as we're putting this in, we're getting H plus and A minus. The more and more and more concentrated this is, the smaller this is going to be in comparison to your original concentration. It doesn't mean that X is going to actually be smaller, just in comparison to what your original concentration is. So for each of these sections that I'm going to go over in class, I listed the pages that I would recommend that you read in the book, and then which problems you can do for homework. I would recommend reading the section about weak acids. There's some information in there. It just reiterates the whole, like the weaker the acid, the stronger its conjugate base, and I talked a little more about the Chavez principle there. I'll talk about it again tomorrow, but I want you guys to read it because maybe we can talk about it more tomorrow. If you've looked over it, then you'll understand it. It's a little bit confusing, but this sometimes comes up in some of the questions. So if you just read that, just that one page, 642, you don't read any of that other stuff. Read page 642 tonight. We'll talk about it tomorrow because we're going to talk about percent dissociation. But with the amount of time that's left, I just want to try one more problem and then see if there's time to continue talking about it. Sometimes you're going to be asked a question like this: what is the Ka? And it gives you percent dissociation, so you have to work that same problem that we just did twice, but backwards this time. So if you already know the percent dissociation and you know the initial concentration, the question now is, what is the Ka value? So you don't know what the weak acid is, so we just call it HA. Then how would you figure out the percent dissociation? You want me to let you try it? No, we've still got like 6 minutes. Okay, this is the last slide. Timing. Tomorrow we'll talk about how to find pH of weak bases. For some reason, people struggle with that more than acids.
We read it.
What's that?
We read it.
You want to put your answers in?
Wait, how do you solve that?
Yeah, if you want to put your answers in, you can. Unless you just heard Davis, so you already know it. And I think Brianna should have it. Do you need me to explain it to you?
Wait.
Okay, oh wait.
Yes.
No, it's good. This is the last question, so no rush. Good job, too. We got through all of it. Tomorrow is going to be bases and polyprotic acids. Then I'll save salts for Monday. Because that won't be here Friday.
We put it in our phones or just?
Yeah, put it in if you have an answer. I see some right answers.
Thanks, Gabby.
I haven't put in the right answer yet.
So it's initial,
Show me, like, units or amount associated with
concentration.
Amount dissociated or percent dissociated? Amount, if it's eight, if you're really finding this, so it'd be molarity. So the units are molar. Do you want me to show you how to do it?
Once I finish the first one.
We've still got 3 minutes.
Yeah,
I only
do
see
it.
a couple of answers in here. Oops. And most of them are, well, a few answers, most of them are right, but they're not all correct.
Do it.
If you know that it's 3.7% dissociated, then what number up here do you already know? Because how do you calculate percent dissociation?
The amount dissociated,
So that's X, what we're looking for, over initial concentration times 100 equals 3.7, correct? So then X over 0.1 equals 0.037?
Yeah,
0.037, and then X equals 0.0037. Yes? So then that is right here, 0.0037. This one's 0.0037. And what's this?
Wait, how come?
Now, 0.1 minus 0.0037, or you can call it 0.1. But what did you ask me?
How come A minus 0.037?
Because it's a 1-to-1,
Oh,
so they're gonna be the same.
and all the other ones we had to solve for that.
And all the other ones what?
We had to solve.
But we're given percent dissociation, so you already know what X equals. So in this is still minus X, and this is still plus X and plus X. But if you're given percent dissociation, that means you already know what X is. So it's telling you what X is, and this is either 0.1 minus 0.037 to 0.1 minus 0.0037 is either 0.0963, 0.0963, or you could have left it as 0.1. And now how do you find Ka? This times this over this, and that gives you Ka. You should have got 1.4 times 10 to the negative 4. It should have been 1.44, right?
Yeah.
Because this is 3, so your Ka value would need 3, so I think, maybe is it 1 point, what did you get, 1.4 something? 1.42? Depends if you left this as 0.1 or you subtracted it and called it to 0.037 squared divided by 0.0963. It's 1.42 less, yeah,
I know.
0.0037.
Is he rich? Is he rich?
1.42 times 10 to the 4. If you left that as